The table below shows corresponding values of x and y for y equals log to the base 3 of 2x. The values of y are given to 2 decimal places as appropriate. Using the trapezium rule with all the values of y in the table, find an estimate for the integral from 3 to 9 of log to the base 3 of 2x. Now, the trapezium rule would have h over 2, where h is the width of the intervals. In this case, that is going to be 1.5. And then we have the first and last y's, and then 2 times the sum of the other values of y. So here, that is going to be 1.5 divided by 2. The first one is 1.63, the last one is 2.63, and then we want 2 times the other values, so that's the 2 plus 2.26 plus 2.46, and we just need to calculate that. And that's going to give us 13.275. Now, since these values are 2 decimal places, you can debate whether or not you should give everything here, but that's where I'm going to leave it for now. I think the answers say anything which rounds to 13.3 is accepted, and my answer does that. Now we want to use the answer to part A, which in my case is going to be this answer here. Making your method clear, we want to estimate these other things. So for B part 1, I have the integral from 3 to 9 of log to the base 3 of 2x to the power 10 dx. Now we have a log law that says log x to the n is n log x, and that's what I'm going to use here. So the 10 comes down, and we can put it in front because it's a constant. Integral 3 to 9 log to the base 3 of 2x dx. So that's just going to be 10 times my last answer, which is 132.75. And I believe the answers say something of the type anything which rounds to 133. So in other words, my answer there is acceptable. Now part 2 requires a bit more work. I'll go through it fairly slowly. So we have the integral 3 to 9 of log to the base 3 of 18x dx. That's the integral from 3 to 9 of log to the base 3 of 9 times 2x. I want to get this down so it's in terms of 2x, just like the original question here and here, so that we can use this answer. So that's the integral from 3 to 9 of log to the base 3 of 9 plus log to the base 3 of 2x. And what I'm using there is that log A plus log B is log AB. I've just used it in that direction to split things apart. And now we can do this as 2 separate integrals. So we can have the integral from 3 to 9. Now let's think about log to the base 3 of 9. That is log to the base 3 of 3 squared. Using a log law we've used before, that's 2 log to the base 3 of 3. And another log law says that log to the base A of A is equal to 1. So log to the base 3 of 3 is 1. So this is just 2. And then we have the integral of log to the base 3 of 2x dx. And that was the first part of the question. That was part A. So what we have here is 2x to be evaluated from 3 to 9, added to what we know is 13.275. So this one is going to be 18 take away 6. 18 take away 6 is 12, so we've got 12 plus 13.275, giving us 25.275.